Not really.
The Tonight Show with Jimmy Fallon.
Hey, Mac, this is mostly for you because we're going to go over quizzes.
Big freaking nerd.
And I'm about to tell people some important stuff about their quizzes. And he can't.
Bro, he can only see you.
There we
But he
go.
can hear me hurl
Yeah.
insults at him.
So if you guys don't mind, I still like to pray when I'm together with you guys. Do you have anything that has come up since, other than our sanity and
People would stop buying too much toilet paper.
yes? Are you running out? If you are running out,
It was $6 at Kroger for 4 rolls. For the
no,
Kroger
was it
brand.
really?
It was $5.99.
See, that's wrong. That's wrong. Y'all text me. I've got.
I'm like, I have toilet paper.
I've still got
So the crazy thing is there's no toilet paper shortage. So after everyone stocks up, guess what's going to be in the store next week?
toilet paper.
More toilet paper.
I feel like my mom buys toilet paper like once every 2 months, so we always have a huge stash.
Yeah. Anyway, let's pray. God, I thank you for this day. It's a beautiful day. Thank you for a chance to make something happen that's somewhat close to school, and for these guys' willingness to come in for the things that they've learned in this tough course. I pray that we will continue to prepare and finish the material well so that we're ready for the exam. God, I just pray your blessing on their lives, on their families. I pray that you keep them safe and under your watch. I pray that you keep them from going stir crazy, give them the opportunity to get out, get exercise, get interaction where they can in wise ways. And I pray all this in Jesus' name. Amen. All right. So I don't want to keep you guys ultra long. And so the more focused we can be, the better. But I wanted to start with quizzes. And Mac, again, on your behalf, if you're watching this, hopefully you're doing so after you got your quiz, because I'm hoping to see you next week for a class and you can watch this video after that. But I'd like you to have the quiz in hand. Here's my thought after I graded them and decided I was not going to count them as third quarter grades. There's part of me that said I should have. And there's definitely a part of me that says, well, when there's bad grades, I'm tempted to question myself, and I'm tempted to question whether we should try to improve those grades. I feel strongly, based on stuff that you guys got wrong, that if you had put in the time and practiced several of each of these types of questions, you would have had no problem. I should have had A's, if not hundreds, across the board on these quizzes. So we're going to go through them. I'm not giving you a lot back. I think fair, probably generous, is that as you work through them with me, provided you stay engaged, I will give you back 1/3 of the points you got wrong. And, that'll amount to a little bit for everyone. Again, I think that's probably even generous rather than just saying, nope, this is it. I really want to know that you guys are super confident with that. So I'm going to give you guys those quizzes back. I'm going to let you look them over a second. We're going to talk through. I don't know that we have to go through every detail of every question, but there's definitely some important things that we have to mention. So that's why I disappeared Mac from the screen. Getting stuff back. Well, he's going to have to do his corrections. And so he might.
So he better watch it.
You might want to at least watch that part. And the next lesson will be covered. So the issue was not the calculator or lack of calculator. The issue was all kinds of crazy things. I guess one of the things that might have caught us off guard is just remembering, at the very least, our trig derivatives. And I was needing you to remember sine, cosine, tangent, cotangent, secant, cosecant, not even the inverse trig ones. Come AP time, you guys are going to have to remember those as well. But I think the one we mostly hit on is having to go backwards from secant squared. And most of you guys remember that was tangent. So that makes question 1 really pretty basic. Remember, a differential equation is a derivative equation. So it's expressed dy by dx, and we're trying to solve for the initial or y function. And so we're doing the antiderivative. So you guys have to figure out what's the antiderivative of 3x squared. That's when we use that power rule that you guys are trying to use all the time, sometimes at inappropriate times, but x to the n plus 1 over n plus 1, which some of you guys forget. The derivative of, well, let's write out the whole function. Yeah, lost a lot of points for plus C. Anyway, someone tell me what the antiderivative of 3x squared is, or how we find that. We don't have to do this in detail for all of them. I can pull the 3 out when I do antiderivatives. It's a constant, and just do x squared, which Jonathan tells me is x cubed. That's it? Because that's not. What's the antiderivative of x squared?
2x.
No.
X squared.
Mhm.
Over 3.
Oh, over 3. Yeah. Wait. You're asking me the antiderivative?
Let's say I pull the 3 out. This is where some of you guys are still struggling. I pulled out the 3 because it's a constant. I can do that and just find the antiderivative of x squared.
Oh, 2x over 2.
No.
2x.
2x over 2 would just be x.
X cubed over 3.
You're going to have to learn your antiderivatives. X to the n plus 1, 2 plus 1, over n plus 1. Do you understand that?
Yeah.
So x cubed over 3, and we still have times 3, right? Now I can see those cancel out, and so it's just x cubed. And if I do the derivative of x cubed, what's the derivative of x cubed?
I didn't do that, but I just put x cubed.
You skipped a step in your head.
Oh.
Yeah,
I mean, you just didn't take the 3 out.
it has to be x cubed over 3. It has to be. You understand that?
Yeah.
Okay. I feel like there's still something that wasn't clicking, but
No. I mean, okay, no, I'm just confusing myself. I knew that, I just didn't say it, but I'm fine.
okay. Same thing here on this second term. I have minus 2. I can pull the minus 2 out as a constant, and I have to know what is the antiderivative of secant squared x.
Let's see.
Okay. I tried to keep them really simple and basic, so I was frustrated for people losing points early on. Question number 2, the only change was when we put in plus c after doing the antiderivative of each term, which should have been super basic. And some of you made them harder than they needed to be. We could actually solve for the c value or the u value. The c value. It was du dx instead of dy dx, but some of you struggle with that. Do we need to go over that one? No. All right. How's about number 3? Again, I would have liked to have had everyone on board. Some of you can't do n plus 1, I guess, when we're dealing with negative exponents. Dx dt equals. I have 7 over t minus 4 over t to the 5th minus 2 x equals -5 when t equals 1. First thing you guys might want to consider is just rewriting all this with t not in the denominator so you can follow the rules better.
T to the -1.
Which I would do now. Actually, I don't want to make things too crazy, but for this first term, I might rewrite it this way. Just pull the 7 out. I have to do the antiderivative of this. I can pull the 7 out. I have 7 times 1 over t. The only reason I might keep it like that is who remembers what the antiderivative of 1 over x is? Natural log x, or t. So this first term is going to be 7 ln t. All right. This would become 4t to the -5th. I'm going to write it here. So tell me what the antiderivative of that is.
X to -4.
Yeah, t to the
Over
over
-4.
Cancels out.
You forgetting that part again?
Yeah.
That part's really important.
Negative.
So the 4 over 4 cancels out, and the negative with this minus sign also cancels out. Y'all understand that?
Yeah.
I have a plus there now. T to the -4th, right? And then
I don't get why that's so important if I'm still getting X. I mean, 2 over X, like 2 to the -4.
I don't know where the 20 came from.
you don't understand why that's really important. It's messing with your constants, with your numbers. If I took the derivative of this, take the derivative of t to the -4th.
The derivative,
-4
t to the -5.
Okay. Is that what you had?
No.
That's what you had up here
Oh, yeah.
when you do them right.
Mhm.
But how did you find the antiderivative? Take the
Well,
derivative of that.
it just, well, I guess whenever y'all talked about it in class, I just realized that whatever it is, it just turns out to be like whatever the yeah, and then I don't know.
That's got to end up maybe canceling out. The thing is, you have to remember x to the n+1 over n+1. Anyway, this just became
Yeah, that's what
minus 2x.
minus
There was
2t
a 6 in front of that number.
plus c, right?
Plus C.
And
He just got rid of the constant
Yeah.
every time. Oh, it'll cancel out.
Well, yeah, because it's working.
Yeah, I got
And
Wait,
if
if I use my calculator for one
I
question.
did it on the first 2 questions. He's like, well,
then it slowly started to decrease.
Actually, it probably would have been that question because I only got minus.
now, here's what I don't know. Can y'all look at the problem? Some of you guys had your C messed up. I think what may have confused you is the X is where the Y usually is. Do you understand that? T takes the place of X and X takes the place of Y. It says dx dt. So when it says X equals -5, this is where the -5 should be, right?
yes.
And T, it says equals 1. So I'm going to put in a 1 here. That was 2 times 1, right? And then I'm going to solve for C. What is natural log of 1?
I have no idea.
1.
Remember what
E.
It's log
ln1 is base what?
E.
E. So we're looking for an exponent that gets me to 1. E to what
Zero.
power gets me 1? 0. So natural log 1 is 0.
Crazy.
Dang it.
That whole term is gone.
Wow.
What's 1 to the -4th?
1.
One.
Negative 1. Wait, no, it's 1.
That's 1 over 1 to the 4th, or
Yeah.
1 over 1. So it's 1. So I have 1 minus 2 plus c equals -5. 1 minus 2 is -1. Bring that over here, and I get -4. Who got it right? I'm not sure if anyone got that right.
I have -11.
Yeah,
Definitely got
lots of
17.
-11s.
Definitely got 17. What'd you get for C?
I didn't.
What'd you get for the C?
C value is what I'm asking about.
I didn't even get.
Yeah, but say I don't think I have no C value.
All right.
I hope we all got 4 right.
This is the stuff that kills your AP grades. Those details. Forgetting the C. Caleb might be the king of that right now.
I never did it anyway.
Yeah, which is why, again, if you worked all the problems, you would have done that. We seem to do a good job in class when we go over problems that someone seems to remember to shout plus C.
That's me.
Okay.
Why are you the only one that challenged?
Obviously not.
You are.
So question number 4, I'm going to leave it to you. The slope is y minus x. So at every given point on the graph, I would just do y minus x and have to slope accordingly. And I think y'all got that right.
Dang, I forgot plus C.
Question number 5. Again, most of you guys did pretty well with that. And I guess the biggest thing for getting the second part of question 5 right is just to match the correct slope field, because y'all see choices B, C, and D look pretty identical in terms of the graph they drew out, but only one of those graphs is correct because it matches the slope field. But if you remembered the slope field that you chose, it's there in letter
See,
D.
I was looking at them like these are the exact same thing. And then I realized those slope fields are not.
Correct. So D was the correct answer for the second part. Graph A was the correct answer for the first part. Euler's method. Do we need to go over those?
Yes.
Okay. I'll take a little time because it's going to be on the test. It's not going to be on the AP exam.
Oh, test.
Yeah.
So I have those.
Why not?
Yeah,
No, we got an hour and a half in here.
Why not?
I guess so. I just thought
Because
about
we
it.
don't want to.
Tests might look a little different when we're in exile. Just because I'm getting you guys in doesn't mean I should necessarily hold you to a different standard grade wise than my other classes, but you do. Ultimately, I desire for you to learn this, and we can do this real quick. We're going to start with our first point. What is the X and Y in our first point?
X is 2 and Y is -5.
All right. What is right at this point? What's the derivative or what's the slope?
0.
Okay, you gave me a formula. Caleb gave me an answer. What is the slope right at that point?
Replace X with, yeah, so 0.
It's 0, right? We're going to do delta X jump of what?
0.1.
And so how do I find the change in Y? I do that times delta X.
So it's 0.
And so let's talk about my new points. It's going to be 2.1, what? -5. All right. dy dx is going to be x minus 2.
Yeah, so 0.1
0.1
times 0.1.
Just
Point
forgot
oh
this
one.
one.
0.01.
All right, and so we would go down to 2.2 and then 2.3, and that's where we would have our final answer. Hopefully I don't need to see it all the way through. That refresher was good. Okay, number 7, an indefinite integral. So it was really just going term by term, remembering how to do the x to the n plus 1 over n plus 1, and also remembering what, Caleb? Plus
I
c.
remembered it in that one.
Good. Go
That's
figure.
the next one. I missed it out on 8.
Yeah, I'm sorry.
All right, so now we're
I
gonna do
was
some.
plus C over anything.
I don't like it.
Not wrong, but
I don't like it.
We're gonna do some substitution questions. This first substitution question is an indefinite integral, so I have to remember at the end of the story there's going to be a plus c, and it said cos 3x dx. We'll find the integral of that, and it says use u equals 3x. So just as a reminder, what is du dx then? Yes, or dx equals du over 3. And so I have the integral cosine u, and I'm going to replace dx with du over 3. And by the way, when I do an integral, does everyone notice this 1/3 or this 3 at the bottom is a constant? So that can pull out 1/3 integral cos u du. What is the integral or the antiderivative of cosine u? Sine u. So I have 1/3
over 3.
sine 3x.
Plus C.
Thank you.
Ah, it's in some of my
Plus
papers,
C.
not on
Right
yours.
here.
Questions on that?
And then
Y'all can do that.
I
Yeah.
couldn't do that.
For all the ones I got
Parker,
wrong,
I wrote it over
minus
here.
25.
Yeah.
That's the only thing I didn't do.
I wrote it in my work,
Yes.
So everything else is right.
didn't put
Yes.
it in the answer.
So it's just
It's
the
on
plus
same
c.
paper.
All right, so turn the quiz over because these next couple of questions were probably my
This is
more
where I broke it down.
significant frustration.
I didn't.
I got progressively
Shut
worse.
your mouth.
Parker, I got progressively worse as it went from 8 to 12.
So 9, 10, 11,
For
12,
some reason,
5.
12 was. I could do 12.
9, 10, 11, 12 should not have been hard.
I got to do 12.
Yeah.
You guys didn't do them. That's the bottom line.
Yeah.
You didn't do them. You didn't do enough, especially when they give you U. I figure the trickiest ones might have been 11 and 12 where they did not. Well, they didn't tell you U for 10, 11, or 12. But if you do them enough, that should have been easy to figure out.
I feel like Mac.
You need to do that on the algorithm.
Mac can hear you.
I feel like Mac.
Mac is listening.
I'm well aware of that fact.
Currently driving. And according to his spam post, he said that the female cannot drive that he's driving with. So nobody's alive.
Yeah, women can't drive.
It's all men here.
John can't drive either.
I've been getting better.
I don't have heard.
I don't-
So do me a favor. Let's take the derivative du by dx, but then let's solve it for dx. It's going to be du over what?
R3 on. No, wait, no. 5.
All I did was take the derivative and then rearrange already. I need the derivative in the denominator.
Negative.
Negative 4 to the third.
Yep.
Cubed.
Okay, that should not have been difficult for any of us to get there. So what I have now is an integral of 20 r cubed over square root of u, right?
Yep.
Times du over negative 4r cubed. And here's what I noticed. My r cubes cancel out, and I have a negative 5. Everyone see that? I'm going to pull that out because that's a constant. Negative 5 times the integral. Let me state u with an exponent. 1 over square root of u would be u to the what?
-1/2.
Everyone else see that?
Yes.
It's -1/2
See, I have this.
du.
Work looks just like that.
Okay, and now to take the antiderivative, I would do u to the n plus 1. What is -1/2 plus 1?
1/2.
1/2 over n plus 1
Ah!
over 1/2. So I have -5 times u to the positive 1/2 over 1/2 plus c, right? And the way I bring that up to the numerator is to times it by 2. So that is -10.
I forgot the impulse one.
I just didn't.
Square
I didn't
root
do.
u.
Yeah, I didn't do over n+1.
Yeah, I didn't even.
Yeah, a lot of you did
I
not.
got that far and then didn't do it.
And then, of course, we have
Where's your C?
plus c.
Doesn't have it.
Loser.
Where's the C?
You look like Wolverine.
Let's do
I like
number
the
10. I'll do these quick. I want to get to the next lesson in the time that I got you guys here.
The bell works.
Yeah.
I'm not used to getting up this early.
Dude,
It's
I-
like 8:12. Dude, I've been getting up at like 1 o'clock.
That is wrong.
I still been, I've still been
That's
getting
the
the normal
sound
time,
time.
but I'm used to playing
Like
Xbox
1
at
o'clock.
this point.
Like 12 or in between noon and 1.
I get up at like, let's say we didn't have this, I'd get up at like 10 to 11.
I,
I
all my
can't do
assignments
that.
were all my assignments were
What's on
due for
your
like
bed?
the next week.
All right.
I did all of
At
it.
like midnight.
Gave you guys some conversation time while I was writing, but I could use a suggestion for you because I didn't tell it to you, but I made this so easy to figure out what we
The
would
thing
use
in the
for you.
parentheses.
Yeah,
Okay.
I mean the
Oh,
parentheses.
wait, what did I do wrong?
I had no idea.
Knowing this, knowing when I take a derivative of the thing in the parentheses, I'm going to have an s to the 1/2, right?
Mhm.
And that's going to be at the bottom of a
Yeah, so
fraction.
cancel
And
out
so I'm
s
going to
to
have
the
some
1/2.
canceling. So u equals s to the 3/2 plus 5. dx equals du over, help me out here.
What did I do?
Derivative, anyone?
2/3 2s
Um,
to the 1, 2.
I'm going to have a 3/2 down here, right?
Yeah. And then
Oh yeah.
S to the 1/2.
C.
And here's a couple of things.
It's the coffee and chips.
Yeah, probably.
Y'all understand the 3/2 at the bottom of the fraction? I can make that a 2/3.
Yes.
Mhm. I
And
don't have a 2/3. That's
I can
I
also
do.
pull it
I
out
don't know
front.
what else
So I'm going to go ahead and do that. And all I have down here is S to the 1/2.
Caleb, did you leave C up again?
Cancel. Cancel. And I have 2/3 times the antiderivative of cos u, which is going to be what?
Sine.
Sine u for sure.
Plus C.
And I know that u is
I did wrong.
S to the 3/2
Plus sine.
plus
Everything
5.
else right. I didn't do sine.
Yeah.
We keep getting so close.
I'm always this close.
Yeah.
No,
But
these
never
next
quite
two-
there.
These next two just have X's.
I just
So
have-
I
I
see
got
this-
12. I got
So
an extra
again,
12.
we should ask the question, should I even be giving you guys any points back? Did I have a right to be frustrated?
Yeah, you had. I'm
Probably had a right to be
myself.
frustrated.
All have rights.
I'm frustrated.
We might have been losing some of our
I am
focus.
declaring martial law.
Big difference in the last two.
Someday I was driving around my neighborhood with the first team player.
What's the big difference in the last two?
You have to
You
actually
have
solve,
to. It's from a point to a point.
Need
C.
plus C. We do need to evaluate it at two different points.
I'm just having a guess wrong, right?
I didn't.
Where did you come from? Cut that joke. Do you know the dance, John?
I don't. I'm just familiar with the tune.
I don't know the dance either. You want to learn the dance?
Let's learn the dance. That should be our Corona. task.
First thing, do you guys know how kind I was here, even though I didn't tell you?
Very.
Very kind.
Very kind.
Very, very kind.
Very kind.
I'll take your word
because,
for it.
The parentheses should most
Take your
definitely
word for it.
because the anti-derivative.
Straight up.
Easy. It's the thing.
Straight up.
You seem
Yeah,
good for it.
it's
Du
I don't know what I do.
equals dt over what?
um
Jonathan, what's the derivative of t to the 6 plus 7t?
The derivative.
Yeah, the derivative.
Let's see, 6t to the 5th plus 7.
Oh, look, it's right there.
It's
did
right,
that.
totally there. So I have the integral from 0 to 1. I'm gonna do some substituting and some canceling. I have u
shoot. I did-
to the 1/2, right?
I did it backwards.
du
I did the wrong U.
equals, let's do the integral. What is the integral of u to the 1/2? I would like Jonathan to tell me.
The integral into
Yes.
that's wait, no, I didn't.
Oh, yes, it is. All right, no.
You're asking for the that's one.
Take a bathroom break, Mac.
1/2. Wait.
It's gonna take 30 minutes.
Is this a trick question?
No.
No, I
it's
want
not
the
a trick question.
antiderivative.
We did it before.
I want to make sure you can do antiderivatives.
Oh,
Oh,
at his
so
house, he does not
you-
take a regular 30-minute
To the
bathroom breaks like he
one-
does here at school.
Well, because he doesn't get out of class on his phone, obviously.
No, but even when he doesn't have his phone, he's
I don't
in there for
The
30
antiderivatives, I'm going to do x or u to the n plus 1 over n plus 1. So I guess the first question is, what is 1/2 plus 1?
1/2 plus 1 equals.
Let's keep it in terms of halves.
Oh, and one, the 3 over 2.
You do the 3/2 over what?
Oops.
And minus
I
1.
didn't do
Right?
No, n plus 1.
Oh, guess what I didn't do?
Guess what I didn't do
N
either.
plus 1 over n plus
You said
1.
3 over 2 plus 1.
No, n plus 1 over
Shut up.
3 over
n
2.
plus 1.
You triple-
Which when I have 3 over 2 at the bottom of fraction, I can flip that and just change it to 2/3. You get that?
Right.
Flip it to 2/3.
Yeah, from the
Okay, yeah. Look at that.
Okay. Now, so what I can also do is pull 2/3.
But wait, I do have that.
No, I'm taking the integral. I'm sorry. I'm not pulling anything out. I have 2/3 u to the 3/2. And I want to evaluate that.
So you just
At
put in-
0 and 1.
You just put in a 1 minus
Zero.
putting in a 0, right?
No.
Yes, and putting in a 0, y'all see, I'm just gonna, that's just gonna be 0.
Yeah.
Uh-huh.
So I really just have to evaluate this at 1. 2 times 1 to the 3/2.
Well,
Final answer, 2/3.
But how come I put that and got an X?
I don't know,
Me either.
but I'll check. I don't have my answer key in front of me. You had 2/3 as a final answer?
Did you get it right, Caleb?
I got minus 0.5.
I got 2/3. And there's an X.
Maybe
I
it's-
knew that it looked right.
I'll double check that one for you.
I got 2
I
to
think it's
the
written correctly.
square root
Two
of
over
8
three.
over 3.
Debatable.
It just said on my paper
it's
that
not.
it's, I didn't cube
Can
it.
you
Oh.
read?
Yeah, I know. Not
Yeah, because I just made a mistake that you guys were warned not to make.
Oh, never mind. I'm wrong.
Yep. So this is evaluated as x goes from 0 to 1.
So
But we're doing this in terms of u.
Oh, you.
So X doesn't go from 0 to 1 or T. We're not doing X's in this case, it's T. When T is 0, what is U? It looks like it's 0 also. When T is 1, what is
Or
U?
it's
7.
It's 8.
It's 8. Whoa.
So this is as U goes from 0 to 8.
That's crazy.
And so
I still did something wrong.
which could be written in a few different forms, but I would have accepted any of the forms.
Big chungus.
Please make note of that after I led you guys to the wrong answer.
Dang it.
That's going to be a big thing. And that's going to be one of those things I'm going to encourage you guys to like spend some time with and focus on before you do the AP exam. If we do use substitution and it's a definite integral, we have to change the limits of integration.
Could you just put the u as t to the 6 plus?
Yeah, so we could have also substituted back in for you
I feel like
and
that's
then
easier.
kept that. And we would have got to the same answer.
I don't have any work for number 12.
So
I
number
do.
number 12, I'm thinking is going to be similar. I'm gonna let you guys talk me through it.
Oh, I do have work for 12. Why is my work for 12 in between number 3 and number 4?
I have no idea, Parker.
Yeah. Look at us 1, 2, 3, 12.
Integral from 4 to 7.
That's not what I'm saying.
I have 1, 2, 3, 6, 8, 7, 11, 12.
Dude, I don't know what I did.
We're doing math.
I want you guys to work me through this.
Okay, we're gonna pick a U.
Okay?
The bottom term.
But that's just.
That's what I did.
Yeah, because it's going to end up.
Oh, you get it right. So yeah.
'cause
Okay, Caleb.
Du dx equals
18.
That
So
means
d
du.
equals du over 18.
So I've got the integral as x goes from 4 to 7, which we could keep it. Parker seemed to suggest he'd rather just switch back at the end and keep 4 and 7 here.
Yeah.
Okay.
I made the same mistake.
So I have 18x over u times du over 18x.
Cross out the 18.
So I have the integral from 4 to 7 of 1 over u du.
LNU.
And that's going to be lnu.
Absolute value.
Dude, I have it on my paper. It says absolute value on my paper.
ln absolute value of u
And guess what I didn't do?
as x goes from 4 to 7. So
Guess what my fatal mistake
I can sub back in for u
I didn't sub it back in for you. Again.
ln
Parker, you know what my final mistake was?
9x squared plus 2
I like Ellen's actually.
as x goes from 4 to 7.
Just give me something.
So all you guys had to do was to substitute in, and you would have had a subtraction, right?
Yeah.
You would have had ln 7 squared is 49 times 9.
Whoa!
Yeah.
You guys tell me what that is, plus 2.
That'd be 443.
Taking
Why
your
does
word
say
on it.
Validated?
This would have been the worst part for you to do without your calculator, but I know you guys should be able to multiply minus ln
146.
See,
Wow.
I didn't sub the U back in again.
I just want to remind you guys of something. I would have accepted that as a full credit answer, but I just want to remind you of a property of logs that you might have forgot. I can combine these to one natural log
Of
as 443 over 146. And by the way, I could also drop the absolute values, because we can only do logs of positives.
I remember that.
What online class?
I said that's one thing you remember that.
He did pre-cal online.
That you can be alright. I
So
don't remember it. Wow.
you guys
Sophomore year.
may give me back your quizzes. This will be actually our first fourth quarter grade as I add 1/3 graciously, I believe.
Yes, absolutely.
We're not working races.
So I'm bumping up to 26.
What did you have to throw?
24.
And I feel better about being gracious after my careless error.
The same.
I don't know what I get
Twice.
myself to.
I don't know, I have a 23, so I'm guessing I go.
So this is basically like a. Why is it schedule?
What's 1/3
Classes.
Dude, Miss Hastings.
All right, so Mac, hopefully I'll get to tell you this in person, but I want your quiz corrections done and handed in. I'll give you 1/3 of your missed points back as well. You may want to watch this also for lesson 7-4, which we're going to do. And then the next time we get together, we're going to have some worksheets to do to build off of some of this. Now, one of the things that I can't do is teach you a lesson and project notes for you to copy. Because I just need the board to be able to write examples and stuff down. So you guys are all getting a copy of your notes.
Is it weird just talking to a screen?
A little bit, yeah.
I don't know how.
Imagine if that was your job, Mr.
Like there's people who do that for a living.
I much prefer to have live people. I started to do this yesterday
Live stream.
with my pre-cal lessons.
I don't
I
understand
like
how
it.
YouTubers do it. Just like, hey guys, what's up?
I know all the time.
I think it's part of what makes all this very antisocial to me. Because they learn just to talk to a device.
I get used to it. I've been watching the movie War Horse at home for history.
Yeah, but
I
as soon as
finished
the
it-
answer key, why are you watching the
John,
movie?
John, I was the
I did
first
watch
one
the
done, I think.
It's a good movie.
It's not bad.
It's actually, yeah, it's a pretty good movie.
Well, I wouldn't know.
I'm about 15 minutes in.
Okay, I watched the whole entire thing the day it was decided.
Really?
Yeah,
That
like
sucks.
literally after, because I had just.
I was
finished doing
watching
something
it, and then it was
got
like,
the email,
hey, I
and
want my
immediately
Netflix
started
account.
watching it.
I might actually still watch it.
I'm gonna watch the interview.
Well, I watched everything except for the last 30
All right.
minutes.
So again, Mac, you'll also get a copy of these notes when you come see us next week. But you guys need to look at the first page is a huge part of this lesson. And we're actually going to kind of gloss through it today. And we're going to come back and practice a bunch of this on Tuesday. But we've seen differential equations. That's just an equation that's written as a derivative, as dy by dx. Sometimes those derivatives, those differential equations, still have both x and y in them. And we call those separable. And we can do this cool little trick. We can separate the y's to one side with the dy and the x's to the other side with a dx. And we can solve for the original equation. And I'll give you an example to do. This is what we're going to practice a lot more of next week. But do you guys have notebooks with like paper? You might want to write some examples down.
I finally got paper.
Oh, you good?
Well, the day of the notebook check, Mac came in with like a perfect binder with like paper, and I was like, "You haven't had a binder for this entire quarter. What did you do?"
Paid
He,
somebody.
no, he
right?
stole mine. Wait, and he got paper, and he gave me some. Did you know that like the public schools, they've been assigning them work, but they can't legally
Yeah.
grade it.
Yeah, that's what I heard too.
So nobody's doing it.
Yeah.
Because it, but,
They can't legally grade it,
No, they
yeah,
can't
because they don't have
grade it.
internet. Some kids don't have internet.
so they can't hold them accountable.
I mean,
So like,
how can they hold accountable?
they just don't.
I mean, we're in a similar boat. Like we're holding people accountable, and yet grade wise, it's definitely going to be a lot more relaxed fourth quarter.
Yeah, Miss Barry's like,
They're arranging
On
a
it,
video
Doc, on
call.
it.
They're arranging a video call, and Peter has a friend coming over, and I'm gonna listen because that's.
She's doing like
Okay.
she's doing like live classes.
She's doing a,
kind of
they're doing a
Awesome.
video chat or something.
Yeah.
We might do that for communications. Let's take a look at this differential equation.
Peter's the best friend page over that.
I like crawfish.
dude, they're good.
Okay, I need to try one of these.
So-
I'm curious.
Usually, just so you understand how this is a little bit different. Yeah, let's get you guys focused up here. Usually we have a function. I'm going to step aside from this, completely aside. We have some function like y equals x squared plus 4. There's a pretty basic function. And if I wanted to do the derivative, dy dx, the derivative of y with respect to x, or a small change in y over a small change in x, what would the derivative of that be?
Oh, okay.
2x.
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 Wow.
2x.
That was about as slow as I think that could possibly
I was
be
focused
given
on
to me.
spicy potato chips.
But here's what I want you to notice. Oftentimes a derivative is only in terms of x, because my original function, I solved it explicitly for y in terms of x. Sometimes, look at this one again, the derivative actually has y present in it also. And so the way we can find an antiderivative, I'm just going to get all of my y's to one side and all of my x's to the other side. All right. I have dy up top over here. So I think I'm going to get my y's over here. By the way, do you all understand this is? So I'm going to divide out the y squared. I have dy over y squared equals, I'm going to multiply the dx to that side.
Whoa.
Okay. All I did was separate them. Now, when I take an integral, I'm supposed to have the dy and the dx present, and they are already present. I'm going to take the integral or the antiderivative of both sides. Let's practice again. What is the antiderivative of that? Or what's another way of stating?
Well, is that like 1 over
1
y
over y
squared dy,
Yeah.
and that's just y to the negative 2?
Okay, so another way of looking at this is the integral of y to the negative 2 dy. Did everyone understand that or get that? And so what is the integral of that? Mm-hmm. I'm not convinced you all can do
Y to
this.
the negative
Over
one,
negative
over
one.
negative
over negative 1.
Okay. And when we say over negative 1,
So it's just negative.
it's just going to be negative y to the negative 1, right?
Mhm.
Equals.
Awkward silence, not yet.
Plus C.
Let's see.
Equals.
Equals.
Antiderivative of that.
Yes. That's all Jonathan.
X cubed over 3.
Look at that.
Good job, John.
Yeah.
Plus C.
Put
it, John.
Dang it, I forgot the C.
Plus C plus C.
No houseboat.
All right. Now,
if we move the C from one side, the C's will cancel out.
except these were totally separate
Totally
integrals.
separate integral, so it's different C's.
So there may be different C's, but either way, we can at least put them together. A constant plus a constant or a constant minus a constant. Do y'all understand that's still a constant? So here's what I'm going to do. I am going to bring them to the other side. I have negative y to the negative 1 equals x cubed over 3 plus in the book when they're deriving this, they use a capital C, just so you understand this C has changed in some way. I hope you guys get that. And what we're going to do now is we're going to figure out C. Thank you, some of you guys that are writing this problem down, by putting in our initial condition. What is our initial condition?
When
Y
y
equals
is 1
1
and x.
Okay, so let's put in 1 for y.
Negative one.
What is negative 1 to the negative 1? Negative 1 to the negative 1 is what? What is that whole mess?
The negative 1.
Some of you are good with that. It's negative 1, right?
Oh, yeah, I thought you meant like.
And then 1/3 plus c.
So to solve for C, I'm going to subtract 1/3 from both sides. Kind of negative 3/3 minus 1/3. What is C going to equal?
Negative 4.
Negative
over
4/3.
3.
So that capital C equals negative 4/3. That means, and I'm going to go back over to this side. Let's write out what I have again. I have negative y to the negative 1 equals, now we move that C,
Oh,
right?
you moved it.
X cubed over 3. Then what do I put in for C?
Minus 4
Minus
3.
4/3.
Now, we want to solve this for y. Let's do this. On the right side, y'all see common denominator?
Yeah.
Plus, can I multiply both sides by negative 1?
Yes.
Yeah, you could.
So I have y to the negative 1 equals negative.
Can I be 1 over y? I don't like negative.
I know.
And then be ln y.
Okay, we're not finding an integral.
We already found an integral, right?
It's fine. It's early.
Now, we got a couple of ways to solve for y. To me, the easiest one is if these two things are equal, flip, flip.
Y
Y'all
equals
get that?
negative 3.
Or I can multiply this over here, divide that over here,
No.
multiply
no,
that
stop.
over there, and
No,
I'm
I
gonna
like
get the
flip. I
same
like
thing,
flip.
right?
Makes sense. Yep.
Y equals negative 3 over x cubed minus 4. That's my original function that has that derivative that's done by separating. So it turns out that is a little crazy, and it leads to some really cool things, some of which I might get into on Tuesday. But I wanted you to see that's what we mean by a separable differential equation. I want you guys to practice one or walk me through one. Do we have that example written?
We need a book.
You should have your books. And by the way, you probably should bring home your books.
I did.
How many books?
John,
do you
which
have
of the
now?
books are you gonna bring home?
No.
How many?
How many at your house?
You got 3, like,
I brought one back.
He has the practice book at his house.
Yeah, I did.
okay.
I had like a good time. I had 3.
Well, the only one out of us, I believe, that's used it
I mean,
is
second quarter.
John.
By the way, if you guys can look in your notes, I made a good point that's going to be an AP test point in parentheses. This particular function Can you guys see there's a point where it's not defined?
Mm,
There's a value of X that would make this 0. So it's not a continuous function. There's a gap or a jump. We have to state the domain then. We can only state for this portion where the 0.11 exists. We'll practice that more in the future going forward. Let's try. Let's try a simple dy dx. I'll keep it simple.
I'm gonna ulcer my tongue. So it hurts. Click my tongue.
Yeah, go.
Yeah, but
Yeah, that's not fun.
it's painful. I them all.
That's disgusting. That's horrible. Trying to consume
All right, you guys help walk me through this
I don't
one.
know how one would feel about it.
Bite off your tongue.
D or y times dy equals x times dx. I like that.
Yeah, I told you I picked a nice one for you. So
Integrate.
Parker separated the variables.
Good job.
Integrate.
Yep.
Come on, guys.
Y squared over 2
Yeah, that.
plus c.
Oh, and then X.
Plus C.
Plus c.
Plus C is absolutely correct, and I'm actually gonna lazily not
Yeah.
write it
Oh, yeah,
here.
because we can just. do
X
that.
squared over 2
Two
plus,
plus C.
big ol' c.
Big old C. Capital C. Baby.
The biggest C you've ever seen.
And then
Like the.
Okay.
Let's solve for that capital C.
Well,
we can do.
the 2 is multiply both sides. No,
no, you can't.
don't do that.
So they have two.
Yeah, don't do that. I don't like
So y squared.
Just
minus
subtract
x squared
minus
equals
or
C.
x
Y
squared over 2 from both sides.
Y squared minus x squared equals C.
Oh yeah.
Yeah, if you subtract.
Yeah.
Y.
Oh, wait, we just put it.
Never mind. Okay.
4 over 2 is 2. So
So
2
2
equals
equals
1 half.
plus
C,
C, which means.
3 over-
equals one,
C equals 3 over 2.
3 halves. Whoops.
All right.
Yeah.
So I've got
Yeah.
y squared over 2 equals x squared over 2.
Plus 3. So we can just do X squared.
And then
plus
all
3
over 2. So you can
You can just
multiply
get rid of
it?
that.
Yeah. You
Sure can.
But
Kill
So
it.
tell me what that would be if I multiplied everything by 2.
Y squared equals x squared plus 3. We solved for y.
Yep.
Yes, why would
Square
we-
root.
Plus size the square
Root
root
of
of
x
x squared
squared
plus 3.
What?
4.
Who said 4?
Square root.
Where's the 4?
He's
Isn't
plugging
it
X
X?
back in. He's plugging 1 back in.
No.
Which that would be a good way to check it though, because if you plug 1 back in, it's the square root of 4, which is 2, so you know you're right.
4.
All right. So actually, what I'm eager to show you guys is what this leads to. And we're going to have some crazy fun explorations of this, like real life. Today's a very practical day, but some of this stuff you guys are going to have to do at home.
No, yeah.
Oh, also.
Yes.
My mom said that she got an email that said the school is closed for like until
3 days.
Oh, okay.
I explained all that when you guys came
You
in.
did. That does something about it.
3 days.
So they're going to make the school a ghost town.
Yeah.
Saturday, Sunday, Monday, which means that there will guaranteed be no coronavirus. Even if, like, the students have been coming in for the last 3 days to pick up stuff, maybe a small chance that one of them had it.
Okay.
Right now, it'll be guaranteed on Tuesday
So why
that there's none.
School every 3 days.
Yeah. I mean, honestly.
Because while you're all doing school, You're gonna spread it.
It was a joke.
so meanwhile, on your guys' behalf, remember,
Sorry.
I'm disinfecting where you guys are sitting. And I didn't let students come into those places. So you can pretty much guarantee now. But come Tuesday, I'm going to have to log. The bigger danger right now is you guys infecting me, not me infecting you. And so I'm going to have to log who was in just in case it ever comes up.
It's Corona time.
When we have growth and decay, which we have in science all of the time, what's happening is that the rate of change is directly impacted by how much of something you have. All right. And, I don't know if that totally makes sense, but it comes down to this. The rate of change, which is a derivative, is directly related to how much you have. And when we say directly related, there's always some constant involved. So we get this differential equation for anytime there's growth, and we do this with population growth or population decline. We do it for radioactivity. We do it for a whole lot of stuff. This becomes a really significant formula. I want you to walk through with me separation of variables. The constant K will keep with the X's.
So we're just so be KX.
Doing the same thing here.
K dx or dy over y equals K dx.
Equals K dx. All right. Then let's do this.
So that'd be obviously ln y. Absolute value y actually. We'll see. We'll do that.
We'll do the C over there, right?
KX. Question mark. KX.
Do we agree with that? If we
Yeah.
took the derivative of that, we just
Plus-
have K?
Let's see.
All right. Now, if we were solving for Y,
So you see this exponential growth thing?
don't know if you guys remember this, but here's what I can do. I can take both sides of this since they're equal and do e to the ln y equals e to the kx. And maybe you remember or don't, the e to the natural log of something, they just kind of cancel each other out. All that I have over there is absolute value of y. Okay. E to the kx plus c, right? Do you guys, well, I'm going to go ahead and do it and see if you get y.
That's so we do that with
That it's not even logs.
you do that with the
That's a
exponential.
rule of exponents, right? If I multiply a common base, what do I do with the exponents? I add them. So I just separated that and
I like it first, I think. It is very
I hate France.
everyone good so far?
Everybody does.
Yeah.
Okay. Watch what I do now. First of all, I'm just gonna flip these because multiplication is commutative. That was awesome.
So it's addition.
And addition is commutative. Good.
Subtraction.
I'm not division. That's that pre-algebra. That's where I learned change the plus to negative.
Now, do you notice this? Look at this e to the c. By the way, if I wanted to make this just y, not absolute value, that means this could be positive or negative, right? E to the c, e to the kx. Do you notice that e to the c, e is not a variable. It's constant, right?
Yeah.
C is a constant.
So it's a constant.
It's just one big constant. So in fact, let me give it a different name.
C just like absorbing
Let me call it capital A.
Oh, no, wait.
Welcome to Constant Town. We're gonna end up with.
Listen, I just have another constant. I'm going to call it A.
Okay.
So y equals A
A,
e to the kx. And by the way, when we do things decaying or things growing, my x value is always time, right? You guys understand that?
yes.
And so this formula actually becomes super important. And this A value, what we're going to find out is that that's actually our initial amount. That's the initial amount that we have to start
I need
with.
to write this problem down.
It's good that you work through it. We're going to take the results of it.
Is that our notes?
Actually, that derivation is not in your notes.
So should we write it down?
Sure.
I like that word. It's a great word. Derivation. Caleb said doesn't like it.
It's a good word.
Yeah, Caleb. What do you have against derivations, Caleb?
You know what?
Take that
Get out.
It reminds him of C.
Caleb is not fond of the sea.
So what you should see is that growth and decay problems are always exponential functions. That is an exponential function right there.
Purge, man. No.
There's a guy driving through the neighborhood. Littering through his car.
Have you seen the video of the guy named Parker who's in the tank? And the guy's like, Parker, get out of the tank. And he's like, I'm in a tank and you're not. You can't tell me what to do.
I have seen that video.
I've not seen that footage.
It's very funny. I just like it because the guy's name is Parker. Parker, get out of the tank. You can't make me get out of the tank. I'm in a tank and you're not. What are you going to do?
Parker would ride that. Shoot, I ran that tank.
Yeah.
I just got a haircut.
People keep following me, but I don't have an Instagram account. They're following some random Parker McBride who lives in Illinois,
Yeah,
or
looks
maybe
like
it was California.
He kinda looks like you. Not really.
Can you show me him?
I can show you him. Yes.
Please
Not
do.
now.
Because John's following him.
He's not yet. I knew Parker didn't have an Instagram.
Now, in your notes, are you guys still writing?
I just finished.
Wow.
Cool hair. John, this isn't
school. There's no rule against cell phones.
Is
there?
But it's a strong suggestion.
See, what did I say?
I mean, I can show you.
If you're scrolling while I'm teaching, I'm going to be a little less than
Like
happy.
we have
But
a little pause
I mean,
right
we
here.
have 6 minutes. I can show
He's
you.
waiting for.
Oh
him.
my
Oh,
goodness.
We're done, right?
never.
Yeah,
Good.
waited too long.
I want to point out one thing that I put in your notes, but I need to make sure you see it. Anytime this value of K, by the way, is called the growth constant. Anytime there is decay, K is negative. Anytime there's growth, K is positive. There is kind of one interesting thing they do in the book, which I don't think we need to do, so I'm going to leave it alone for now. But it's there in your notes. If you look at the second page, the second line down says the constant K is the exponential growth constant or the exponential decay constant. In one case, K is greater than 0. Anytime we see a decrease in population, K is less than 0, right? The way this is, I'm sure it's done. I'm sure there's a whole lot of calculus that has gone into.
We can still do it.
Yeah, we can still do it.
I heard there's no.
It'd be
We'll see when the
relevant to-
coronavirus becomes like sure, but I heard there's.
You guys would have to do a little bit of research to find some information, but we could definitely do it.
I heard there's a medicine for it.
It was because Canada's hockey season got canceled,
It's
so
not-
they started working on it.
Yeah.
It's like you know what's it called, Tamiflu, like that kind of thing.
Okay. Now, our time is limited, so let me show you a couple of things. There's some really practical application, and one of them is to take a function for compounding interest. This should ring some bells from last year and earlier this year.
Just per-
Yes, take the normal formula is actually not that. It involves your initial amount times 1 plus there's a formula to follow, but that also helps define E. All right, I don't want to get into all that, but the bottom line is when we have continuously compounded interest, that formula A equals PE to the RT, the PERT formula, comes from doing what we just did, right? It comes from actually doing a separation of variables of a differential equation, and all you're going to be asked to do is apply the formula, the PERT formula, which hopefully you guys have an easy time doing. All right. Also want to talk about how we get half-life formulas from this. If this is our Y equals, instead of saying A, I'm going to use Y naught, Y sub 0 as our initial amount.
Okay.
That sounds like a British person. That's how British people
Yeah.
call zero.
That's right. That's correct.
I watched this YouTube channel called Number File. And they say that all the time.
So if we wanted to do, you guys know with radioactive materials, they do what's called a half-life. What do we mean by a half-life?
The amount of time that it takes for it to lose half of its.
Okay, the amount of time for it to have essentially lost half of itself or to be half of what we started with. So if we wanted to calculate a half-life, I want you to look at this one real quick too. This Y value that we end up with is essentially going to be 1/2 of my beginning value, right? And I have Y naught E to the KT. Do you understand? These Y naughts essentially cancel out. It's always going to be irrespective of how much we started out with when I calculate half-life. How am I going to solve for half-life or for this T time? Check if you guys remember how to solve exponential equations.
LN2.
LN.
You take a log.
Take a log of both sides. Maybe we would do ln because this is
It's got an E in there, yeah.
On both sides.
so ln 1/2,
Yeah.
which, yeah, let's write it like that because I can show you something.
KTLNE.
Equals, when I do the ln over here, Parker's saying that could come in front like a multiplier, KT lne,
I remember that.
LNE is
I'm actually using pre-cal.
and lne is just 1, right?
We don't
Yeah.
need the LN.
I feel like it's the first time I've used pre-cal this year.
So t, if I'm solving for t,
You divide this by K, so ln 1/2 over K.
I'm going to write ln 0.5
All right.
Okay. That makes more.
over k. That's how I would find half-life of anything. And again, I want to point out that it has nothing to do with how much you started with. It only has to do with the decay constant. Now, I think Caleb was probably looking in his notes.
Yes.
You guys see it says ln2 over k. I'd actually rather you go with this. I want to show you guys something.
No, we're just blinking at you.
Oh, okay.
How do these two relate to each other?
Well, you see.
Well, I don't
Well-
know.
One is a half.
So not, you might think,
Was that kick?
One half is not half of two.
you might think it's a
It's
fourth.
a fourth of two.
One's ln is.
Translate this for me. I might have you doing your calculators in a second.
Okay, two.
What's the base?
Z
E
equals.
to what power
I have no.
Oh,
idea.
that's E to the x
equals
2.
2? And this is
E to
E
the
to
x
what power equals 1
half.
over 2. Do you understand that these are just going to be negatives of each other?
Yeah.
One's going to be positive, one's going to be negative. So I actually find it a little more accurate to go with this ln 0.5 over k, because this is going to end up being negative, right?
Mhm.
But I want you to remember k is also, because this is half-life, it's decay, k is also going to be negative, and that's going to give me a positive value of t. When I created these notes, I followed the book. The book wants you to put in k as a positive number.
That's great.
And so that would be an appropriate formula there in your notes. ln2 over a positive value for k. But to me, I'd love you guys to get in the habit every time we're doing decay, my k value is going to be a negative. Think that way, and let's use 0.5. So you guys might want to write that in your notes. All right. Last thing I want to say really quick. There's a very cool formula called Newton's law of cooling.
Cooling.
And essentially, and calculus teachers love this, by the way, which means we're going to take a little more time on Tuesday to do it, because it's calculus. But if I have a cup of coffee and it's too hot to drink, but I bring it into a room that's a certain temperature, and we're pretending that we're not using Yetis or any of these special thermal cups, how long is it going to take to cool off to where I can drink it? And we actually can use calculus to figure that out. I gave you the formula there in your notes. You guys are welcome, nay, encouraged to go through all of that. But I hope to see you guys back on Tuesday at the same time. We're going to end. Max, see ya.
This didn't seem as long.
Bye, Mac.
For some reason. Felt shorter.
Because
we're not used to